Patrick from our demo, product manager for demos from the Qt group. The stage is yours.
Right. Thank you. Yeah, so like Tapio was mentioning, so I'm a product manager at Qt. I work primarily with the demos, but also with the automotive and tooling, which is why I'm here talking to you today. So for those of you who don't know or maybe haven't been kind of doing that much stuff, oftentimes when it comes to the actual design and development of HMIs, there's kind of this not a zero-sum approach. So it's always one or the other. Either the design takes headway and then you pay for it in the end in development, or then it's the developers who get to lead the way and maybe the design doesn't always meet what it should. So this presentation, we're going to look through some of the kind of key things that can be done on how to optimize this and work in a truly design develop way in cross-collaborative methods. But before we do that, one thing that it's really great to always touch on is what is product management and where does a product manager actually sit? So maybe I'm a bit biased here by being a product manager, but basically a product manager is a professional responsible for overseeing the development and management of their product through the life cycle. And they play the critical role in the center there of the entire development process, kind of trying to keep the balance between business needs of their own company, technology needs, technology developments, as well as the actual customers' use cases and what they need to be solving, the problems that they have. In addition to this, there's also the inner workings. You've oftentimes probably heard of the relationship between the PM, the head of tech, and then your lead designer. And so it's this common balance and the common kind of collaboration which ultimately creates the best things. And just to even highlight this, so where the product manager is most responsible, or where kind of the core thing that they need to bring to this mixture is overseeing the management throughout the life cycle. So it's not deploy and forget. It's not build a feature and let it go. It's not just do whatever you want. At the same time, you have to keep everything about the priorities straight. So the technical priorities, the design priorities going forward. And so that's why there's, basically, there's kind of this meme in a way that it's, ultimately the product manager is the one that you have the responsibility. You get to dictate the direction of the product, but you need to do it based off of these inputs, based off of this information and all of that. And the reason for one other thing is basically, and I can say this also as being a former product owner, so here it is, it's like, tell me the truth, product owners don't have any authority. Part of this comes to the next slide, product market fit. It's the thing that will ultimately make anything successful or ultimately cause it to fail. It's that common balance between market needs and product deliverables, whether it's UX, feature set, value proposition, or then also the customer's target needs, etc. So that's enough about the little bit of a background. Hopefully for those of you who it's, the idea of what a product manager should do doesn't always be what they do, but should do. Will kind of help set the framework for now talking about the next step, the software-defined vehicle. So how are some of the trends that we're seeing, some of the trends that we're working for, ultimately making it into the real world? So the first trend that I'm sure everybody knows about is a lot of the automotive manufacturers, the OEMs, want to transition from a car maker into a software company. I mean, you can see this with Mercedes, you can see this with BMW here. So they no longer are thinking about, okay, how can I just sell the actual hardware, through the dealership, sell the actual vehicle. They want to get into the long tail. They want more, higher margins, lifetime value, lower cost of acquisition, because basically you're upselling. They already have the hardware. I mean, it's basically what Apple and a lot of those software companies have done for years. They sell the hardware very cheaply, and then they get you in the long run with the actual software. So that's one of the core reasons why a lot of them are looking to do this. But what's needed to create a SaaS product for a car? Well, OEMs need to build the software platform. So if they're all the time being basically pushed around, dictated by what their actual software providers, what their tier 1s, tier 2s are doing, then they're going to start to run into problems because all of a sudden you're not able to move in the direction that you want to move. You're moving in the direction of what your suppliers are moving. The second big trend that we see a lot is the increased exploration of new technologies. So this is kind of one of those things where it's basically everybody is looking for, kind of the next thing. What can we offer more? How can we move forward? How can we be different? How can we meet the product market fit? This can be, for example, streaming experiences. So apps, inbuilt apps. So predominantly in a lot of the Asian markets, you're seeing the heavy integration of actual applications, so third-party mobile app store type apps being brought into the vehicles. And a big reason why this is because the OEMs are constantly asking what needs to create a modern UI for a car. So what is creating that modern experience? How can you be cutting edge? How can you be what everyone's expecting from a consumer product, like a vehicle? And then the last one is basically HMIs are gaining more of a smartphone UI UX. So this is, pretty much everything in the world is moving to the hyper kind of consumerized experiences. So they're combining, 3D gaming, focusing on the actual cockpit experience. So it's no longer just, okay, there's gauges, but when you get in the car, how does it feel? What does it do? How do the lights come on? How does everything interact with itself to make it different, make it unique? And at the same time as this being extremely interesting, it's also extremely dangerous because there's always the question, what are we going to do next? What are you going to do next? Who's going to go there? So you're always having to push the bounds, always having to push farther and faster. And once again, when you don't own the actual software, when you don't own the platform, when you don't have that in-house knowledge, when you don't have that expertise, the combination of design and develop, it makes it extremely hard because once again, you're at the mercy of your tier 1s, your tier 2s, or your other providers. And what does all of this actually lead to? Well, basically, the main thing that is the problem here. The dynamic that's driving the need. There's new technologies are created every day, and old ones change. There's all sorts of new design tools. Like right now, everybody's interested in Figma. A few years ago, Figma was a small startup. Very few people actually used it. Everything was done in Adobe or, those types of programs. 3D. Blender is getting really big. You'll have all sorts of Maya, Fusion 360. So these things that everyone's looking to try out. And in 3 to 5 years, maybe they're still around, maybe they're gone. The same when it comes to specialized tools for actually doing, say, the animations of certain elements. So you want to build them out, and you need to incorporate those. And finally, the actual technology side of things. So you have the engineers looking at the wide range of different OSs and platforms that they can use, and as well as the backends. So what is the car actually going to be connected to? How are these software applications actually going to interact with the vehicle? And ultimately, if you're not careful, what happens is you create a zero-sum game. So there's always will be one side that wins. It's either the technology side, it's the designer side, etc., like what I was talking about earlier. So a lot of times the issues comes when basically the design and development doesn't start the discussion early enough. So they wait too long. Or then you turn into have the problem of basically passing artifacts. So you have a designer who builds out something in Figma, and then they hand it off to the R&D, and then they kind of wipe their hands, and that's it. And that causes all sorts of frictions, because maybe there was something that could have been done in a more optimized way. Maybe there was something that should have been better thought about. Maybe there's some new technology that the designer didn't even know was possible, and they're not able to incorporate that, and there's an entire missed opportunity. And what's the final result? Delays, high cost of development, and ultimately everything becomes just a big pipe dream of missed opportunity. So now, how can it be done correctly in the software-defined vehicles? So one of our customers, Hyundai, has done a great example of this. So they're using Qt for a lot of their HMIs, and basically they wanted to create an entire kind of range that could go across all of their different vehicles. So as you know, the Hyundai group has many different classes, many different logos, many different versions. So they basically wanted to make sure that everything could be developed in a consistent way, that they could reduce the amount of different softwares and technologies that they're doing to ultimately decrease the costs, and hopefully make everything just that much easier. So basically, the way that they did this was by kind of creating separate layers, by bringing things together, and ultimately creating a new way forward. So in concrete details, looking at these three problems that I brought up earlier, the way that they did it was their exact pain points, touching on these ones that they had earlier, was they had a shortfall to the software-defined vision. So basically, speaking too fast here, need to slow down. So this fragmented software made it very difficult for them to do this. So they had different brands, different engineering groups, different teams who were ultimately doing everything separately. And this caused a lot of time and caused a lot of issues and basically caused them not to be able to iterate fast, which, as we all know, in the software world, that is it. You need to move fast. It needs to have version after version after version. That's how you learn. That's how you develop. That's how you make it better. Also, since everything was everywhere, they weren't able to collect consistent data. So it was very difficult to get that actual information in about what's happening. And then finally, they couldn't get that consistent identity because everybody had their own layout. It might have been tweaked just a little bit. This person has a button here in its vertical stack while someone else uses horizontal, etc. The second pain point was the skyrocketing development costs. So like what I was saying earlier, basically, there's a lot of high maintenance cost. The reason why was because everybody was doing their own thing. So even though one team might have kind of a bit of capacity, they're not able to actually come and help out one that's short-handed because, well, there is no shared knowledge. There is no shared technology. Everybody was doing their own thing. Every lineup, every edition had its own variant and its own software architecture. And then the last one was basically a lack of software scalability. So they couldn't start to plan for their future vehicles because their tier 1s or tier 2s, even in some cases, were the ones who were ultimately making the call for them. So they weren't able to say that we want to use this particular hardware, we want to use this particular OS, we want to basically have everything structured in this way. They were going with what they were given, and that ultimately was steering their direction as opposed to them taking ownership and having their own OS and hardware combination. So what did they do? Well, basically they did a couple things. So first, they started and created a new division. So this was the entire thing, that we're going to start from scratch. The way that we were built out, the way that we were structured, doesn't work. Next, they had to define what the platform was going to be. So starting at the basics, what do we want it to be? Where do we draw the lines? What is going to be consistent? What is going to be modifiable? What are the rules going to be of that platform? Next, they created the CCOS, or Connected Car OS development. So basically, this is their own way to solve the problem of kind of the cross-platform hardware. And I'll go into this in a little bit deeper. Next, they created app templates. So this is very similar to probably what a lot of people or a lot of you have done in your own companies. So you have a layer that is essentially a reusable component. So that way you can make things faster, you can make them easier, and you can make them better. Then they created the UI components, so to work with the apps. So you basically decouple the functionality from the visuals. So that way then you can mix and match as need be. And finally, the design, develop, workflow improvement was achieved because of all of these different steps. So, like what I was saying before, basically, whenever they were defining the platform strategy, they basically made the decision of how do we want this to be. So they decided to define a platform policy to declare full ownership of the software. It was theirs. They wanted it, and they didn't want to be steered by anybody else. Once they were able to define the software and the hardware, then they were basically able to use their leverage to dictate that to their tier 1s. Once again, large company, it's a bit easier. But where it's kind of stopped at was essentially they used NVIDIA Drive CX, and then the OS was Linux, and then on top of that was the UI framework done with Qt. So here's a very high-level description of essentially the architecture that they used. So we have Qt at the top, and then the actual Hyundai ownership of the platform plus the connected car. So as you can see, they have multiple different apps up at the top layer, very abstraction. Then below that is you have the app templates, basic components, and then the actual assembled components. Then we have Qt framework, which is talking to the connected car, which is running on embedded Linux, and then across whether it's Qualcomm or NVIDIA, depending on what is the actual hardware or the actual in device that it's going to be. So is it an infotainment system or is it a cluster? After that, basically, they started to develop the connected car system. Basically, the way that it worked was it's a standards interface stack development by Hyundai for their new platform team. So it allows them to connect to, it allows them to establish a stable connecting environment and processing vast amounts of information and data coming from the vehicle control systems. So as you all know, cars have many different interfaces, and all of them need to be feeding that data back into the ultimate, or into the kind of higher level. The system was made basically on the premise of APIs should be unified across the platform and across different OSs and hardware to be reusable and future-proof. So this is kind of the basic idea of, whenever you're actually trying to decouple the functionality of a component from the visuals of it. So you want to have an API which can be trusted and is true and is built for that. And that's what they were able to achieve within their connected car OS. So once again, going into kind of a very busy slide here, but you can see in even greater detail. So they have the actual HMI layer at the very top with all of the different functionalities, all of the different elements there. Then they have the application framework layer. So you might have a setting manager or a collection manager. Then below this is the actual connected car. So this is the functionality. This is where kind of everything meets the hardware. So you have your vehicle, navigation, security, etc. And then below that is the actual hardware abstraction layer. And then finally, the Linux system running on the actual board. So whenever they needed to, so the way that this worked is basically like what I was saying. So they have the multiple inputs, whether it's a steering wheel remote control, the centralized control system, or then the HUD, cluster, display touch. So basically, they have to manage multiple inputs and outputs. And the system needed to be defined in a way that it would be able to do this, that it would be able to share the data across these different views and give a consistent experience to the user all at once, regardless of what the display resolution is, what the display type is, and what the look or feel of it is. So basically, they built it out in a way that they would be able to build for the future and plan for the future and build for the next generation as well as the current. So yes, the app template. So having just the connected car wasn't enough because basically there was still this gap. So they have their side, but they still have their tier ones. And they needed to communicate to the tier ones basically what it is that needs to be done. So Hyundai decided to basically fill this gap by using the standardized application structure. And the reusability and maintenance was dramatically improved because, once again, it is all reusable, it's all componentized, it's all packagized, and then it can be taken further. So actually, Hyundai worked with us to create a unified standard for this application implementation and ultimately the app template. And here you can see basically what the app template looked like before and after Qt. So before, you have a QML UI, so your screen, your UI component, etc. Then you have this C++ logic, and then below that, the connected car. So after working with us with the new version, so they were basically able to create these templates where they have a UI common component, which is then connected to the actual UI component. And like it says here, I mean, this made it easier to maintain and standardize the application structure. There was also less human error because you're no longer actually adding in the C++ logic. You're able to just reuse the API logic and connect there. And then The solution number 3 that they used was UI componentization. So this is kind of what I was talking about, where it allows the designers to be the designers while you can still have the developers be the developers. So the developers are able to work at the app logic level, while the designers are able to work at the UI level, only focusing on the components there. So they were able to make basically Hyundai-specific components that were these cute quick controls too. These would be reusable across the different lines, across the different models, and ultimately make it much, much faster and make it much more consistent across the brands, regardless of what the level is or what the exact manufacturing logo was. And this ultimately allowed Hyundai to undergo a UI update twice per year, meaning that everything or the speeds, time to market and the speed of iteration was massively decreased, and they were able to ultimately get a faster time to market, which always is giving the better iterations and getting the better feedback quicker to the designers and allowing them to ultimately make it better. So here's, once again, the concept of the component. So essentially, you would have app 1, 2, 3, 4. Then these will talk to the common components, which then basically go into the actual functionality of them. Some of the core benefits was basically, like I said, the speed, the ease of development and deployment, the maintaining, since everything was at a single level, and ultimately they were able to move faster. So for the last thing, I've been talking about a lot of this, so what does it actually look like? So here you can basically see the cute quick controls at the top, and then the basic components here, and then the assembled components. So it's a very simple, basic kind of UI, very basic elements, and then they match here that, okay, the digital clock will be there, it has certain functionality, you can have different items, different videos, images, different buttons, etc. So basically taking the separation of what is going to functionally happen when you press the button and what is going to be shown as the button. So I went apparently really, really fast. Yeah, that was it. All right. Thank you.